Hello guys, welcome to another video series where I'm going to be talking about session management and RAG pipeline. So on this video, I'm going to dive deep into a technical series, and today I'm covering to a related topic, which is session management and the RAG pipeline. So, and the session management is about continue. The session management is about continuity and how do I remember context across multiple messages. And when we are talking about, and the right pipeline is about the knowledge. How do I grant agent a response in your document and data? So we're going to be talking about the session storage abstraction, MongoDB and Redis implementation that I did to manage the session. And of course, you could I plan to extend it so that if you guys want to choose anyone, if you don't like MongoDB, you could go for PostgreSQL or use any other relational database or DynamoDB. So I'm going to be talking about the right pipeline architecture, document injection for multiple format, vector storage and retrieval. And here, session management problem. Here is the challenge. A user has a conversation with an agent and the conversation span multiple messages. So each message needs context from previous messages. So where do I store that context and how do I handle scale? What if I need to switch storage backends? So different use cases have different needs. So and a chatbot might need Redis for speed. An enterprise app might want MongoDB for rich query. A local development, you might say you want to use like a SQLite. So this is the reason why I need an abstraction that supports all this without coupling my code to any specific storage. When we are talking about the session storage, I'm gonna dive deep into the code to show you guys where I have a single interface. Uh, Let me show you. Yeah, I have it here. Now, if you look at here in the session management here, this is where I have a single interface. If you look at here, look at the project structure because I'm trying to explain all this project, how I built it so that you guys will get along. And here, we have a different kind of method functions here: create section, get session data, add messages, retrieve history, list user section, delete session. So any storage backend implementation, any storage backend need to implement these methods. So the rest of the system only use the interface. So if you look at here now, it means that we have this create session, we have the get session is true, we have a create table if not exists, we have the update session, list paginated session. So it means that any storage backend like Mongo session, Postgre, uh, 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 Progress session, uh, need to implement this. So it means that it's going to be like a concrete implementation for this. So I'm going to dive deep into. Let's look at the MongoDB implementation, which is right here, right from the code. You can see it here, even though I have the presentation slide. I mean, in a reading here. This is the configuration for the resilience for any MongoDB operation. This is I'm still using a registry pattern, right? Because I want to like register this and make it auto discover as I've explained in the previous video. And if you look at here, uh, if you look at here, I'm trying to create the table if it doesn't exist, right? So if you have like, let's say, PostgreSQL, it means there's going to be like different way where you're going to create the table. It's a different syntax. So you implement them differently. And for example, here, create section, I try to create generate UUID, right? I check if I'm in the async context. If you look at it, the code is well documented, right? And here, if you look at this code, I'm trying to generate if there is UUID before here, because this is like I'm trying to create a new record. I generate a session ID for it. This is runs create async, and this is a create section async. So you could go through all this and try to get a feel of how I implemented each of the functionalities. And you can see here as well, when I'm adding message, I'm trying to, I add async retry. Should the MongoDB service is down, I still want to retry for a certain number of time based on what I configured here. If you go to here, based on all this, the maximum attempt, delay, retry strategy to be exponential. So as I was explaining, if you look at the key implementation details here, decorated registration, which we use for auto discovery of this session, sync operation with thread pools. I'm using PyMongo for synchronous, so operation run in thread pool. So smart hybrid pattern detect async context and handle say accordingly. Resilience, which I'm using as the async retry. And of course, we have the type safe, because if you come here, uh, uh, I'm actually using, I have some messages that I define here. If you look at here, chat message session, so which is, these are the two communication mode that I created in the process for the purpose of data exchange. So if you look at this, same thing. I currently I don't think I've not implemented the Redis, but as we want to implement the Redis, this is still going to follow the same pattern, right? So maybe registration storage, this. So the objective is for this to follow the similar pattern, so that if I need to get access to the section, I could get access from the factory. So these are different way we implement it. Looking at it, I have like a registration storage, right? In case we want to do the implementation of Redis. And look at the registration factory here. It means if you add like I have Redis, right? I have a Postgre, I have a MongoDB. So uh, if you need to add a additional session storage, maybe this is not what you want. Or maybe in the fourth coming update I'm gonna push, uh, I might have update on different backend storage that maybe implement a DynamoDB. So it's still going to follow the same pattern. And here I'm using a session registry, right? If you see register session repository, if you check, you notice I'm using the same here. I'm using the same at register repository. Look at it, at register repository. And this is what I'm using to register the session, right? So the same thing is going to be applicable to this. Look at it. Look at MongoDB repository. Look at register repository, and look, it has different implementation of create table, right? So this is an elegant way that I am using to handle different kind of session management. It's not necessary that you have to use MongoDB, Postgre, DynamoDB. I mean, your organization may decide to just choose one, decide to use one. I'm just trying to show you how that should be implemented, or how I implemented it here. So you could take it as a base knowledge, try to expand it, and extend it, the GitHub is open for contribution. You could also contribute to the GitHub. And this is the factory I created. The factory here, this is where I'm getting the section, right? A section registry, uh, section repository registry, get factory, and then I return it, pass the list of keywords argument here. So, and the key features then is I'm using decorator, right? Lazy loading, uh, repository only imported when first accessed. So type saving, because if you look at here, I'm using type saving because when you want to get, I'm getting repository type. So those are the key features here, and there is auto discussion. I mean auto registry discovery. So look at the sample usage here. Let's say I want to use MongoDB, right? In my application, if you check, I make reference to MongoDB. This is how I'm going to use it. So if it is for Redis, it means that this is going to check to Redis. Or if it is Postgre, this is going to check to like a Postgre, right? Then I'm still going to continue with this base implementation. Imagine I have this base session factory, base session repository, which has a creatable, create this, create. So it is flexible. It makes the code to be more flexible. And here I'm trying to show different examples on how to add a message to it. So, and in case the section asks some other metadata, you could also do that. Just the section data is equal to this based on what we have here, right? This is section data, it's a dictionary. So it could take any form of data. So which means that it works seamlessly for MongoDB, for Postgre, or for any backend infrastructure. The same thing applicable to update. So by default, you may say session factory.get default, right? So which means if you go to the section section factory here, you go to the section factory here, it has a get default. You see, I'm using MongoDB as my default. So I'm just trying to show different way. How do you extend the new session backend? So this is how to extend it. For example, if I need to add a DynamoDB, I need to add a DynamoDB here, and I need to provide a concrete implementation for it, just like Redis, MongoDB. And if you need to access it in the application, look at it here. You just need to access it directly here. So I'm going to add a MongoDB implementation, or maybe you guys need a different request, or you have like a Microsoft SQL Server, or you have different storage, or Cassandra, or you have anything you want to just post in the comment section. I'm going to implement it and update it, and so you guys will have access to it. So before I will proceed, guys, because I want to talk about RAG pipeline, but I want to dive deep a bit. I want to a bit dive into before I will dive into RAG architecture. Let's talk about the caching. In an agent system, making frequent LLM and API requests, caching is not optional; it is essential. So looking at here, this is where I implement. If you look at here, I implement some caching strategy here, right? I implement different caching strategy here that I'm using in my application here. So I just want to show you briefly on the caching how it works. You can read more about it in the documentation that I provided. We are using the same registry pattern, which is what I use in element provider in the connection in so many of the implementation that I've done. I have two cache type I implemented Redis and in memory, right? And of course, I have the base catch provider. So get, it will set, it will delete, it check if it exists, and it will clear the pattern. So now, if you look at this cache, if you look at this, so guys, if you look at here, I have the cache registry here where I'm trying to. So I follow my design system follow the same pattern throughout the application. If you look at it, cache registry dot register. Let's say this is Redis. This is where I implement a Redis cache provider, right? I implement a Redis. This is where I have the implementation for the Redis, right? And if you can see here, I'm trying to use some sort of decorator-based exception to catch exception. So if there is an exception, it will return null. At the end of this is still gonna log it, right? This is gonna log it and return. If you check my exception implementation that I did, so if you see delete, see in memory as well, in memory cache provider. So which also implement base cache provider. So if you have a different cache you want to use, you can follow the same pattern. For example, this is where I have the factory here. You can just get through the code and understand it. And if you look at here in the factory, I have for common use case, the framework provides some pre-configured instance. So if you check the code, everything is there. I'm just trying to walk you through, for example. This is an example, right? Await cache.set. I'm trying to just provide the key to set it. So if you check the code, you are going to see how I use it. And I'm also catching the LLM response, right? So these are just different sample implementation. And in the conversational sign-up, I'm catching the user details as well before I finally save it. You see, clear all sign-up state. And this is how I'm handling the error. This is a decorated pattern that I use and to catch error. And that's why I'm able to use this kind of a pattern here in the code. If you check the implementation here, for example here, and to catch error. So this is the implementation for the catching that I have in this application. You could take it as a base, extend it, use it, refine it, and then if you also go to the data source, you're gonna see how I provide configuration for the catch there, right? Where I'm using Redis, I say catch, type Redis. So here I have Redis rules, and this is a common attribute to all the new one. And if you want to add a new one, of course, here is it. All you need to do, say, let's say main catch, you implement the implement provider with decorator, right? You could do all the implementation, proceed with everything, and this is the way I implemented the caching in the application, how I efficiently manage it. Now, let's talk about the RAG retrieval augmented generation. The idea is simple but powerful. Instead of relying uh, only on the LLM training data, I give it relevant information from the document. Take note, all the tools I implemented as well. For example, when I implemented GitHub tools, Confluence, Jira, Datadog, there is still a way to give more context to the LLM instead of the pre-trained data that comes with the LLM by default. So if you look at here, a user will ask a question, what was our Q3 revenue? LLM, I don't have access to it. I don't have access to your company financial data if there is no RAG, right? But with RAG, user could ask information about your internal data, and that those internal data are now going out. They sit within your system. That is why we have some sort of RAG implementation for it. So uh, if you look at it, RAG enables like a current information about your organization or about your company, about your business. It has a private knowledge of your business domain. Um, you could start a specific document in response. It actually reduces hallucination, right? Because if you look at it, uh, as long as the LNM have the understanding of your, have the knowledge of your business domain, internal knowledge, private knowledge, then it will reduce hallucination. So, and it also reduces cost efficiency because no need to fine tune a model for domain knowledge because you already know that even though you are still the best practice to do that. So now, um, let's talk about the document injection. If you look at the document injection, this is the RAG pipeline. Injection is done. It's just one time. Phase two is to query the document. If you look at in this all this implementation, what I'm trying to do is first I detect the document type. If you check the injection service here, check file injection service, right? In any injection, I have different kind of functionality that I put there. But if you go through this code, you see the major implementation I here is I detect the document type. If it is PDF, I extract the text and then and structure. For Word document, I pass the Python doc. For Excel, so then I choose the document, the content, because when you read the PDF, when you read all those documentation, when you read the content, you have to like uh, you have to convert the text in the, you have to try to chunk it so that the LLM will be able to use it so that you embed the chunks. So take a look at this. It is important for you to just select where do you want to embed the document. This is not gonna, we have some database specifically designed for vector embedding, and I did some implementation. We have a PG vector, right? We have a lot of vector database. If you come to the DB, right? Look at it, Chroma DB, this is also good. PG vector, Hydra. There are a lot of them. You could use Cassandra. I think it has embedding type too that you could use. So here I'm just showing different implementation. All of these to extend like a vector, which is the base. If you come here, this is the vector, this is the base class. So I'm using the same design pattern all through. If we check it here, check the injection service, right? This is where I'm trying to inject the file. This is file-based injection. If you look at the major operation here, and you could also check it supports, I could say, okay, attract data provider to register a conference. Maybe if I want to embed my conference because of the cost. Because if you have to be making API call to conference document, a conference document that really change, I think it is the best idea to just embed it into your vector database so that you not incur additional cost. But even as at that, I still provide a direct access to conference. It could be different kind of a document. It could be file. Let's say you have a, let me try to explain it here. If you see data source on that, like here, let's say we have some file, we have some document. This is a directory. We have document in this directory. We have another document in this directory. We have this in this directory. So it will work. it will work even if we have a cascading directory inside here, right? Let's say inside here we have some documents, and inside there we have another docs in another directory. So it works seamlessly. Try to pick them up. Those are the one I classified as what? File. So if you see file service handle or those kind of uh, uh, um, those kind of files from the file system. Anything from the file system, that is what this file service injection handles. Now let's talk about the retrieval. When a user query comes in, here is what happens here. When the user asks a question, the relevant document are retrieved and added to the prompt. Look at it. I say, for example, this is a user query, right? I say vector db, get vector db. Of course, I supposed to get it to factory, right? If you check the application, I'm getting it to factory. This is where I retrieve the document from the database, right? From the vector db. I convert it into like a text, right? And I'm going to try to return it. And the LLM will try to use this information. LLM will try to use uh, those information that I retrieve from database to reason and take decision based on whatever user asks the LLM to the application to do. The flow is you retrieve the data from the data source, you present it to the LLM. LLM have been trained with a pre-trained data, huge amount of data. So all the LLM need to do is just to use what was returned from the database and use it as a context to provide a customized response to the user. And if you look at the configuration here, it follows the same pattern too. If you come here, embeddings, this is where I'm choosing. And you know, if you want to embed into vector database, you have to choose different kind of the embedding provider. OpenAI, Hugging Instructor, Cohere, a lot of them like that. So this is where you need to choose that. So just follow through the code to understand the implementation that I did. And we could also check the data source to see, for example, the example usage. So this is the best practice here is that you have to apply chunk strategy. So even if you retrieve a PDF, but thanks to launching, it has a lot of rich API that you can use to read different kind of file system, and which will now break them down into a document. So, and when you receive the document, you still need to chunk it. So you can break it into different tokens so that it will be able to work efficiently. And you select the embedding framework you want to use, OpenAI, this and this, and then retrieval tuning. You could start with 3 to 5 chunks, so as to too many of these will actually lead to noise, right? So we need to do some sort of performance as I just did in this implementation. So that is the session management and RAG. Together they provide continuity and knowledge for meaningful agent interaction. So in my next video, I'll look at the service and API layers, showing how all these components comes together into actual handling. Thank you.